In this video, we'll be looking at acceleration problems where we're solving for time. So we're going to use our rearranged formula from the formula sheet. Time is equal to final velocity minus initial velocity divided by the acceleration. So the problem we're going to look at is a sprinter on a high school track team can achieve an average acceleration of 3 meters per second squared from rest to his maximum velocity of 11 meters per second. Calculate the time taken by the sprinter to reach his maximum velocity. So we're going to start like any physics problem in listing our variables. So we have an acceleration of 3 meters per second. So acceleration equals 3 meters per second squared. We have an initial velocity, it says rest. So if we're resting, we're not moving. So that means that our initial velocity is 0 meters per second. Anytime you see the words rest or stopped, it means that that's our initial velocity. And the last piece of information that we have is our final velocity. So this maximum velocity of 11 meters per second. So that's our final velocity. And so we're solving for time. So we don't need to do any unit conversion here because everything's in meters per second squared. So we're just going to take our formula, time equals final minus initial divided by acceleration. So we're going to have 11 meters per second minus 0 meters per second, all divided by 3.0 meters per second squared. So 11 divided by 3 gives us 3.7 seconds as our final answer. So just a quick aside as to why the units work out here is we have meters per second divided by meters per second squared. So when we divide by a fraction, what we're really doing is multiplying. You may have heard the term kiss and flip at some point in your schooling. So we're multiplying by the reciprocal. So we flip the fraction and multiply. So our meters will cancel and our seconds will cancel out that squared. So we are left only with our time feature here. So that's just an aside as to why the units work.